Hello, hello. Hello, and welcome to today's episode of Plumbers of Data Science. Today without intro because I was super late. Somehow, YouTube didn't let me start the stream. I don't know, I had to refresh the site and so on. So, yeah, today we are... Hi, Nick. Welcome. Today we are going to look into Pinterest. Yeah, I have found a lot of interesting stuff on Pinterest. There are some slides from SlideShare, but the main resource today is from Medium. I'm more and more impressed how many companies are putting their stuff on Medium, and it's super. I'm impressed. What I'm thinking is that they want to get engineers from putting out information of what they're doing, and this might help them get good people. Yeah, Nick, it's a live stream today. You're the only one watching, I guess. Oh no, there are coming more. Okay, hi guys, welcome to today's stream. We're going to look at Pinterest. So let's dive right in. Let's dive right in. Let me just quickly organize here the slides. No, this is wrong. This here. This is what I need. Okay, so again, Pinterest, they have an engineering blog on Medium, which I find quite good. It's totally worth watching, worth checking out. By the way, as always, I'm going to put all the links to the resources we were looking at in the description after the stream, so you can check out in detail stuff that we're going over here. As always, we're going to skip a lot of stuff because otherwise these streams would take 3 or 4 hours, so you have the time to watch the stuff. Yeah, the first thing, let's maybe quickly, if you guys don't really know what Pinterest is all about, let me just get up Pinterest here for a second. Okay. So the idea is with Pinterest that you're searching for Pinterest is very visually a social media platform, and the idea here is you search for stuff and then you pin it onto some pin boards that you have. So now this is usually I look at it on the mobile device, so I don't really I'm not really familiar with the UI from desktop. So usually what you can do is you can go and look something, and then you can pin this to one of your pin walls. So I have a few pin walls here. I think it's called pin walls, and you can pin them to your wall. And so when someone is going on your and is looking at your pins, you can have the walls. So let's say you have I have one with Art Deco, so then you can and then you have this stuff, and you can look at it, you can go to the sides, and so on and so on. And so you can pin stuff to your pin wall. You can follow people, as always. You can do comments and so on. So this is the idea behind Pinterest, and it's a bit different than, for instance, Instagram, where the pictures that you like or something, they stay on the profile of the one of the guy that you're liking. With Pinterest, they appear on your pin walls, and so you can do huge pin walls with a lot of information, which I find quite interesting. It's more a system to collect stuff. Yeah. And so the first thing that we're looking at is they have one from September, article from September 2018, building a dynamic and responsive Pinterest. And this is basically is a bit of what they're doing. And yeah, they have data in SQL database and in HBase. So they're using key value stores, and it's taking them very long to query. And so they have for instance, this is the following feed. I don't need to describe what following means. So you have the API, and then what is this? Follow list, follow service. How does that work with the numbering here? So you have basically a follower list in a MySQL database, and a service that is forwarding to you, and then you can pin stuff from them, and this goes then into a HBase database. So it's pinnability. Mm-hmm. I think this then might be a image or something that you can pin. They have a score. I'm sure they go further in here. I don't want to read all this because this is quite boring to read for you here on the stream. Man, this is not turning out as I was hoping to. This slide here. Okay, here you can see another thing that they have built. I'm guessing this is the figure 1 is from 2015. So they must have built something new, which then goes here. The problem I have here is they have a lot of services and databases they named. I guess it's all proprietary stuff. So it's quite hard to follow. Like here, real pin is a highly customized object retrieval system providing rich data and so on. So this is they are building stuff, and they are renaming it. But basically, as you can see here, for instance, here is a Kafka instance. This is we have seen a lot of times. APIs post into Kafka and then into something like a database feed generator. Yeah, okay. Interest feeds, how these work. Interest for user. Then you have pins for this interest. You're getting them both from HBase, and then you're getting a list, and this is again the smart feed worker. I'm not 100% sure what this. This is very recent. So this is in any case worth diving further into. It's very detailed. So this is data stored in Aperture. I'm not sure what this Aperture is. RocksDB. This is this one here. Rockstore. So I think I need to check this one here a lot closer. Anyway, this is I think this is very interesting for getting understanding of what they're doing platform wise. And this is another one. What was that one? Building pin stats. So this is tied into the first one a bit. Statistics for pins. And this is basically how they implemented it. The statistics. You have your mobile phone, and this mobile phone is shooting real-time events. So this can be I would say these are API calls here that are coming from the app when you click on stuff. And then what they're doing, they're saying they do some online filtering, so they don't store all the data that is generated from the device, because they might not need it. And they try to save data because they're, what was there, somewhere here they said 100,000 or more events per second. Where was that? Of course I can't. Yeah, no. Approximately 100 billion events a day. Yeah, so a lot of data. Dragonfly asks, when you say API calls, where is the call being made from? The call is being made from the mobile device. So when you click, you have on this side, you have a let's say, for instance, a web server, and there is a API running, and the device is making calls like JSON calls to the API and delivering data to the API and getting data back from the API. This there is another there's another slide we're going to get to this in is that the next? I think it's the next slide already. The next article already. So what they're doing, they're filtering it a bit, and then it goes into Kafka, and from there they are writing it into S3. So they are backing up everything, and then they have hourly or daily pipelines running, depending on the type of analytics, the type of statistics you're running. They say MapReduce. I'm not sure if they still use MapReduce here or if they really used MapReduce. So they have a hourly pipeline, and this goes then into storage, or a daily pipeline, and this is then shown in the statistics for the pin. So it's this Nick says it right. This is basically clickstream. Clickstream with your thumb or with your index finger. I'm not sure here is why they do filtering. Why they filter it, why they create more real-time events that they basically that they actually need, and then filter them out on the server side, or filter them out somewhere. Why not concentrate on stuff that you really need, and then you don't need to do the filtering? I'm not sure why this is why they're doing it like this. No idea. Yeah. So they are doing processing, storage. Yeah. Maybe they. Yeah. At the same time, online filtering is extremely expensive here because it can involve various network calls, increased latency. Yes. Maybe there is more information on filtering. There are 3 hits here. Yeah, so it still doesn't make sense here. Another big challenge was filtering the high volume of events each second, so we don't populate our pipelines with data we'll never process. Why? Our, our little one. I have the baby phone again. Let's see if she needs some help. Yeah, so I'm not 100% sure why they do it like this, that they are filtering, but this is basically clickstream processing and very simple that you have then the impressions. And let's check my analytics. Oh, overview. Oh, okay. This didn't work out as I thought. Okay. So somehow I again need to log on. I don't know why. Okay. All right. Another thing here. I just want to just quickly. Where was that with the APIs? Okay, maybe it was in this slide. Yeah. So Pinterest story of streaming hundreds of terabytes from pins to MySQL, from MySQL to S3 continuously, and S3/Hadoop. This is a slide from October 2018 from Henry Kell. Yeah, let's go over this. This slide is the first part is quite interesting. The other part, it gets really into detail and without taking a lot of time and maybe some explanation. I found it hard to understand. 100 billion pins and 2B boards. Okay, I don't know. So they have a lot of users, more than 250 million active monthly users. Yeah, data driven. Okay, personalized recommendations, spam. Okay, of course, spam control, search quality, A/B experiments. This was what I said a few streams ago, that they are doing experience with A/B testing, and you don't really know that you're one of the test group. Related pins, data pipelines. That's 1 petabyte of data per day, 10 million messages per second. That's a lot. 800 billion messages a day. 2,000 Kafka brokers. This is a large setup, I would say. 50,000 client hosts. I'm not sure what they specify as client hosts. Then, yeah, ingestion, online logging, of course, database, snapshots. 2016 pipeline. This is interesting. So they have the app, they have Pinterest services. These are, I would say, these are the APIs that we see and that where we interact with, and these don't really need to only be logging APIs. These can also be APIs to share data to. I mean, APIs especially for logging, like say Clickstream for user behavior. These can also be very simple APIs to get data to the mobile app, and they also log data, and they log the data into Kafka and into real-time consumers like Spark Streaming, and then into S3, where they are working with Hadoop Spark, Presto TensorFlow. So they are also doing some analytics here, and then they're doing some backup stuff, local backup from databases. This is also going into S3, and then you can basically merge it with the data that you're getting live. This is how I would say this stuff works here. Can I get this bigger here? Okay, this is a bit better. Then, yeah, they have some versions. As you can see, they have a sharded database. Yeah. And they, it's a bit it's not as sharp as I would love to have it. Yeah, they say Hadoop streaming. I don't really know what they mean with Hadoop streaming. So they are doing some dumps, and then they are streaming some stuff. And they are putting it. Okay, this would be this. I guess is MySQL dump here. It goes into Hadoop, and then it's getting mapped and further processed, I guess. And version 2, they have databases. These create local CSV backups. And then I'm not sure what this tracker thing is here. And then they put it into AWS again. Let's go further here. Is there more information? So they are more or less in the second version. They are more or less working with CSV database backups, which is actually a good idea that you're then because CSV is super easy to manage. Dragonfly asks, so is the sharding keep 3 copies of the data? Usually, if I remember correctly, with SQL database, when you do sharding, it's more or less you're splitting the data. So in shard 1 gets some data, shard 2 gets some other data, and with I would say within here the data is replicated, but this is a way of parallelizing a SQL database. Correct me if I'm wrong. And so, a traditional way of parallelizing stuff. Pain points. Reliability caused by MySQL hosts hiccup. Okay, so they have some problems with MySQL hosts. Pulling over 100 terabyte data daily, but only a few terabyte changed every day. Yeah, so they are processing a lot of data each day, but they most of the data doesn't change, stays the same, and so it's basically, can you call this cold data? So it's not changing data. It's it's hard to explain here. I would say this is more or less than cold data that doesn't get changed, but data that is used over and over and over. And they have a long latency in this setup, so it's 24 hours to get database backups and then analyze them. I would say, or do the backup. No, not analyze them. Do the backup from MySQL to S3 or to Hadoop. Real-time search indexing, real-time recommendation engine. Yeah, this. Okay, future. Then they have a new pipeline. Data ingestion now. Let's go further here. So the thing is, what they, as you can see before, no, it's maybe I can show it in the small here. The thing here was that they took the data from the databases and they put it into S3 and then remodeled it through processes or through processing and put it then in a new structure into S3 again, so you can analyze it. And in this new setup, what they're doing is they are doing the backup of the databases through Kafka. So they have a Kafka Bridge, DB Kafka Bridge, where they extracting data from the databases, putting it into Kafka, and then with this, the cool thing is you can put it through your usual pipeline. So if you have a real-time pipeline already running, or you have a batch processing pipeline running, that where you are going to get the data, store it into S3, and then process it with whatever TensorFlow, you can use the database from use the processing from, or use the old data from the databases and put it through the same pipeline and work with it, which is quite interesting, I think. But this will then increase, of course, the load on the Kafka. Yeah, Kafka Bridge Maxwell, that doesn't ring a bell. This is how this thing looks. So here are the shards again. This then end up in a binary file, and this file then bind log trailer thread. So they are okay. So it seems like they are working with some binary data here, and then they're queuing it in memory on the node of the replication node, and then they are producing it asynchronous to Kafka and into the topics. For instance, the user topic or the pin topic, which makes sense. Yeah. Watermill. Okay, they are compacting stuff from the databases. Okay. Yeah. Okay. Yeah, now it gets super complicated. I have to admit I haven't looked into this very detailed, because it's quite detailed. This is getting more. It's getting even more complicated in the slides to come. They have, the cool thing is they have here some data lifecycle. That's but I have to say this is has a lot of information, and maybe you can check this out when you have some more time. I'm just going quickly through it here. If there is something interesting again. There are some nuances with Kafka. Yeah. Message order is always a problem. In Kafka or in these situations. Delivery. We have talked about the delivery methods, or the how was that called? Delivery schemas, delivery options of messages. So at least once delivery because but in this case, at least once you can have duplicated messages, which might not be that good for analytics or for statistics, depending on the error that you might have. Dealing with cluster hiccups. Yeah, this was, by the way, Dragonfly, when we talked about how to make sure on Kafka if messages are getting received, or you can use with producer acknowledge. This is a way to tell that Kafka 4 topics. So yeah, Nick asks, as far as I know, message order is not a problem for Kafka if topic is not splitted in partitions. Is that right? Yeah, funny thing is we had this discussion at work today, and with Kafka and the message ordering, I always thought that there is another layer, that the topic is always basically ordered. The thing is, this is actually not true. So how it's work, of course it is ordered. If you have a single partition, then it's super easy, but it's partitioned. If it's a partition, if it has like 5 or 6 partitions, every partition has its own offset, and the messages are ordered within the partitions, but not ordered over the topic. So if you have one partition that is getting bigger, and you have 4 small partitions, the order is not really over the partitions, is not really the same. So it's not that it's not that easy. It's not or simple. They asked, but why need partitions for the topic then? You need partitions for the topic so you can write in parallel as quickly as possible and have as much parallel processes as you can. Because if you write to a single queue, you're limited to that single server. If you have 4 partitions, you can write 4 partitions in parallel. And if you write into 4 partitions in parallel and you have something like Spark, you can have 4 executors reading from those partitions in parallel. And so this scales, of course, up. Does a producer have to subscribe to a topic before producing the messages into it? Ask Dragonfly. Nope. No, producer can just produce. Producer can just produce and send data to it. Yeah, okay. I'm going to skip the rest here. You can check everything out in the description after the stream, as I said. Yeah. Another thing that I found interesting, and I have this is a super basic post. It's from 2016, but it's still valid, and I find it interesting that people are having problems or don't know exactly what autoscaling is. So just a quick quick overview of autoscaling. The problem is when you let's say you have a hardware cluster or you have a usual system, your platform is going to load wise, it's going to go through cycles. And what they say here, a typical traffic pattern for one of our services. So this could be, for instance, a day. It starts at night. This is let's say this is the morning. This is at lunchtime, and these are the evenings, and then you're going back into night, and so you have a uneven distribution of your load on the systems. one way to handle this is you're looking at the peaks, and then um, you're buying as much hardware and setting up as many systems so you can survive these peaks, and your system works very good during these peaks. But as you can imagine, this is not very optimal in terms of costs because most of the time you don't need this peak performance. And so what you want to do is you want to have load balancing that is scaling up basically the instances. How this works is let me just so you have some instances, and now the load is getting super high, and you're watching, basically you have a metric system and you're watching the whole platform, or you're watching those servers. Let's say those are the API servers that are serving the just a second, guys. Guys, I need to take a quick break here and look at one of our childs. I'm guessing she's not really sleeping that good. I'm back in hopefully a minute. I'm leaving you guys on your own. Do you want to have the music on, or should I keep it silent? The delay. I'm going to keep it silent. All right, I'm back. Yeah, let's see how this goes. If it doesn't work, we need to cut the stream for today. Where were we? We were at building an auto-scaling group. The idea here is you have your servers here, and these are maybe APIs, and those APIs, they are serving the apps, and the higher the load, so the more people are working on their phone, the higher the load is getting on those apps. And you have some metric system that are getting into or getting measured by CloudWatch, and at some point, what is going to happen is that a scale up alarm is triggered, and when this is triggered, let's say you have two. In this case, you would have two servers here. A scaling up is triggered, so it's scaled up, so it launches another instance of your web server, and from this point on, you have three. And then you're working with those three servers. And at some point, basically here, at some point, the threshold here is triggering another alarm, and it's telling the system to scale down. So it will remove a instance from those three. So graceful shutdown, terminate, and then you are going to end up again with two instances. And in this way, you are very flexible with your setup. You can cope very good with high loads, with peaks in your system, and it's very cost efficient. So what you're going to then, was this an old? I think this is how such a thing works. They in this case, what they are also doing, they are having a different auto scaling group for different AWS instances. So they have a on demand group, and they have a spot instance group, and they are scaling them basically. Independently. Dragonfly asks, Andreas, are you currently working with cloud systems? Yes and no. I'm working with cloud systems, but I'm not. I'm working on a private cloud. I'm not working with Amazon, for instance, or with Google. Where I'm working with Amazon is, for instance, on my blog. My blog, andreasgretz.com. This is a blog that I have set up on AWS. So it's a EC2 instance. I'm running WordPress on it, and so on. So there I have some experience with AWS, but to be honest, this is not really rocket science. So I'm sure the devil is in the details, but most of the things is not that hard. Amazon autoscaling looks like Kubernetes conceptually aimed it. Yeah, it's gee, I wonder what's behind this service. So I'm guessing they are running such a system in the background, heavily modified. Yeah. Here's a overview of how they basically managed or how they improved. So CPU utilization in their case here is basically a flat curve. It's basically, as here you can see, the auto scaling is really working, and you can see the group size also interesting. So you're starting these are the evenings. You're starting high in the evenings, and then around 12 at midnight it's going down. So the groups, the auto scaling scales back the instances, and then in the morning the instances get again scaled up until around, what is that, 2 o'clock or 12 o'clock, and then throughout the day they stay high, and so they achieve a quite good CPU utilization. So this is what you do with auto scaling, and this totally makes sense. And this is a very upside of having such of being on for instance AWS, where you have this built in. You don't need to set up a Kubernetes system, and you don't need to Dockerize everything and so on. So yeah, this is quite nice. What was that here? Health checks. Okay, doesn't matter. Okay. Yeah, now another thing that I found interesting. This is less of a technical stuff, but what they're also doing, building real-time user action counting system for ads. I always asked or questioned how do ads get delivered to you, and basically or selected, and basically what they're doing here is you have the front end, and you're viewing that page, and the front end makes an ad request, and this then here's a point candidate retrieval. So they have an ad inventory, and through a clever process they are basically retrieving ads and selecting the ads that are maybe worth for you, and then they select winners, and those winners that then get added to the front end. And if you click on that, so again, Nick, clickstream, if you click on that ad, it generates an action event that goes to a logging server, and from that into Kafka, and then into Aperture, which is for viewing then the data. Yeah, and here are also getting counts. The winners are also counted, so you can see how many winners do you have, or what gets or what ad wins the most, and is it getting clicked. You can then compare those two together. So yeah, it's interesting. They have some approaches on how to do this. Client-side events counting, independent counting service. Some comparison between the two. Storage schemas, query languages. Yeah. I mean, for me the main thing here was this clickstream thing. That is interesting. Of course, this here is where the how is that called, the IP, the intellectual property, lies. Having an ad inventory, selecting the right ads for the user, and then letting them run, and then of course tracking the whole thing, where you need pipelines for. Yeah. Another thing was databases. They have a database called Goku. I haven't really looked into this. This is just as a thing for you. If you are into a time series database, Goku follows open time series database model. So this is a interesting thing if you are into these models, and if you want to get into time series database, they say latency is very low with less hosts and so on. So yeah, what's next? Okay, this I'm not 100% sure here. So I just want to show you Goku. This might be interesting if you're into time series databases. Why did I select this one? As you can see, you can find a lot of stuff just on Medium. And Nick asks, guys, what is the clickstream template here? And what is the best clickstream template? Maybe I can add new features to my current template. Template to use clickstream. Yeah, one thing. Let's go back to the pipeline stuff. What was that? Was it this? This is. I mean, this is basically the same. I mean, you should look into two things. What do you want to do? Do you want to do real-time processing? Or you need two templates more or less for real-time processing, for streaming, and for batch processing. And as you can see, one thing that we can see over and over and over is that you have an API, you have something that is collecting data from the client, or that is communicating with the client, and that is logging data into the Kafka stream. And from there, you are connecting a analytics engine or a framework. And most of the people use Spark here, but as you might remember from a few streams back, you can also use what was that all we've been looking at? Storm, Samza, and Apache Flink or something. So you can use stuff like this, or you can just simply if you're on a, I mean, the thing is always also for the deployment. So if you're running something like a Cloudera instance or a Cloudera distribution, it's super simple. You get the parcels for Kafka, you get the parcels for Spark, and you can run this basically also on AWS on EC2 instances. So you set up the instances, set up the cluster, and then you create some APIs, and those APIs directly produce or into Kafka. If Kafka produces JSON, I mean, the JSON template itself, of course this is all JSON here. I mean, the JSON, of course, it depends on what data you're collecting and what you're measuring. But just a super simple JSON. I mean, I don't know. As I said, it depends on what you're handling. And then you have your streaming, and also what you're doing is you're logging each of the JSON messages into a S3 file, and so you're getting a file that is building up, and then you can use that file and Yeah. Yeah, and then you can analyze it. Dragonfly says, I wish I know what template is in this context. Yeah. Well, the thing is, what I'm guessing is, and this is also when you look at stuff that they are also using, stuff like Goku and so on. My guess is what they're doing is they're sending messages. They have in the JSON a timestamp, basically when the action has happened, a identifier of the action itself. This might be a few types or classes. So you can have let's say a home page, and then you have some functions under the home page. So you have a hierarchical thing, or you have multiple. Are they called tuples? So you can define a very fine, or have a fine definition of what metric you're collecting, and then you're creating or you're transmitting a value for this metric. How often has he clicked or something, and then you just put it in the JSON and send it over, and boom, that's it. So I don't think this is super hard. Yeah, and then you put everything, for instance, in like a time series database, and you can measure everything. Maybe I should do a post about this. But overall, JSON is a good choice, and yeah, it depends on the use case. Yeah, it depends on. Yeah. Nick says like timestamp event. Yeah. I mean, there are multiple ways to do this, but I would say, yeah. This was, yeah. I would say we leave it with this. I have some other things here with improving H-based backup efficiency at Pinterest. They have some. Looks like they have some problems with backup. Yeah. I should write this down. Last thing I wrote down was Jenkins. JSON template for clickstream. Okay, maybe I can make a short template that I would say for the next stream. Don't know how much time I have tomorrow. Yeah. So a few other things that you can look into: improving H-based backup efficiency, cloud native stuff. Yeah, stream sets. Right, Nick, you mentioned this last time. Yeah, and okay, this was the analytics. I had another one on the. What was that? Yeah, that was super super complicated, so I left this out. But I'm going to put it into the description. That was how they budget, how they set up the stuff for the streams and the messages. Yeah, okay. Guys, as always, please, if you like this one, hit the like button and look into sharing this. Please share this with some friends. I would like to get more people in here. Somehow, I'm not sure if I'm not sure if this is the wrong time slot, or I'm not sure what I'm doing wrong. Statistically, I should get some more people in here, but let me just check the statistics from this stream. Yeah, you guys are here, which is awesome, and I'm happy that you like it. But I'm not 100% sure what I'm doing wrong here. To not get more people into the stream. So we had 28 visitors basically today. Maybe it's the time slot, maybe not. I'm not 100% sure. Dragonfly says I have an idea. Sure. Let me know. That would be great. Because I think for topic wise, this Nick, this is I'm guessing this is the problem here. The problem is I'm starting at 10:30 in the evenings here, and so basically everyone east of me is basically asleep, and I think it's three something for India. So these guys are asleep, and no, it's not that. Yeah, but I'm trying to share the recordings to get the information out there. On Friday, I don't know if you have seen it. I did no, it was not on Friday. It was on Thursday. I did a short stream about how to build a data engineering PC or a data science PC that you can also do machine learning and deep learning with. There was basically no one there. There was one guy there, and he didn't talk. And so after 20 minutes, I bailed. Dragonfly says instead of 5 days a week, reduce it to a couple of days a week. We can then build a momentum around it via LinkedIn and social media. Get one in on a weekend, and I think you should have more people in that way. Yeah, no, I'm. The thing is, I thought about it. How often should I stream? And the weekend is also always family time. So weekend is weekend. I cannot do the weekends, and I committed myself to do everyday stream. So people, if people get around and finding this stream, they know it's going to be every day the same time, and also I can share some stuff that I find cool and that I like. One thing I'd like to bring up one more thing here. A comment from LinkedIn. Let me just pull it up. There was a question from LinkedIn, and I think we can answer this here quite fast. Let me just bring it up. There was the question from Rohit, who basically said, my question leading from a older post of mine, can you or anyone reading this kindly point out a real world use case where a relational database storing more than 1 gigabyte of data needs to be queried in this manner? So query it in parallel, on that you need to query entire 1 gigabyte of data to extract information. Thanks. David has written some stuff here. The thing is, I think, Rohit, this is basically the case studies that we're looking at. This is a use case more or less every day for these information. So or for this processing, these companies are working with a lot of data, and it's very, very quick to get in this amount of data, especially if you're running batch jobs and doing batch analytics, like we have seen with Pinterest, where they're doing analytics once an hour or once a day for everyone. So yeah, so I think these type of questions are necessary, but yeah, it's basically very, very, 1 gigabyte is not that much. And especially if you're looking at machine learning, where you query for the training a lot of data and then analyze it, 1 gigabyte is nothing. Okay, guys, I can try one more thing. Another thing is, you could have at least 5 dedicated people who can make posts online. Those platforms I mentioned can make a generic post using the YouTube link to drive engagement. Yeah, don't worry, don't need to make a post tomorrow. Yeah, I'm doing my best here. I'm trying to cut small pieces and share them, for instance, on LinkedIn and on my Facebook and so on. So yeah, that stuff works. But if you find something here interesting, just make a screenshot and make a quick post somewhere and link to the stream. That would be awesome. If you like something especially and want to point something out that I maybe have forgotten, just make a post and make a screenshot. Don't worry about don't worry about anything that it's my material. If you like stuff, and if you're some part, like, share the video and it's okay. Put it somewhere. Yeah, Nick says, can make a post about stream sets because I'm using it daily, but not sure about this week. That would be awesome. We can share if you're doing this, and if you're doing it, for instance, on Medium, we can share it in the Plumbers of Data Science Medium publication, and yeah, and on LinkedIn and so on. So yeah. Okay, guys. That's it for now. Let's meet tomorrow. I'm not 100% sure what to review tomorrow. I need to look into this. I'm going to share that tomorrow morning, what we're going to look into. Yeah. For everybody watching on the recording, all the links are in the description of the video. And if you would like to support me, you can support me on Patreon. Just throw in a few bucks and yeah, help me or support me on this endeavor here. You also have there the access to the newest cookbook with the links to the case studies. And I'm going to update this more and more. Okay, guys. Again, thanks for watching, and see you tomorrow. Now, if I could find the stop streaming button.